Hello everybody. This is lesson 11 of the lecture International Financial Markets. I will discuss slides 121 to 130 of chapter 2, Major Market Segments and their Assets. In this lesson I will talk about markets for forwards and futures. What are forwards? A forward contract is an agreement between two parties at date T to sell, respectively buy, a particular asset at a particular price at date T plus X, so at some future date, in other words. The two parties may be private companies, private investors, as well as financial institutions like bank and insurance companies. The particular asset is also called the underlying asset. I will use the term underlying asset in the following. And this underlying asset may be a financial asset, for example, fixed rate bonds, stocks, and so on, as well as standardized goods. For example, raw materials, intermediate products, precious metals, grain, lean hog, whatever. The particular price is also called delivery price or contract price. I will use in the following the term delivery price. It does not change over the whole period from point T to point T plus X in the future. Point T plus X is also called the maturity date of the forward contract. So this means that a forward exchange contract, which we have discussed in the lectures before, is a forward with a currency as the underlying asset. Another terminological point is what's the difference between forwards and futures? Well, of course, from an economic point of view, there's no difference. In practice, the difference is that futures are standardized contracts which are traded on international markets, while forwards are agreements which are custom made between two clients, typically of commercial banks. But by construction, both assets are the same. Let's make an example how the price of a forward contract is determined at the date of maturity. For example, let's assume that two parties agree that one party sells, the other party buys a stock of corporation XYZ 6 months ahead in the future at a delivery price of €100 for one stock. Now let's consider what the value of this forward contract will be when the market price of the stock in 6 months will be €80. Let's start with the value of the forward contract for the selling party. Selling party has to sell the underlying asset, the stock, at a price of €100. If the market price is, however, only €80, that means that the selling party can sell an asset that has a market price of only €80 at a price that is equal to €100. So the selling party will make a gain of €20. That means the selling position in this forward contract at the date of delivery will be €20. For the buying party, then the opposite is given. The buying party has to buy a stock that has a market price of only €80 at the price determined by the forward contract of 100 euro. So the buying party in this situation will make a loss of 20 euro. Now let's hope that the price of the stock does not decrease but increase to 150 euro. Let's now consider the price of the selling position in this forward contract for the selling party. The selling party has to sell the underlying stock at the delivery price of 100 euro, even though on the market the value of the stock is 150 euro. So this means that the selling party will make a loss of minus 50 euro. For the buying party, the opposite is given. The buying party will make a profit of 50 euro since it can buy the stock at a price of 100 euro only and can sell it immediately on the spot market for stock at a price of 150 euro. So it will gain 50 euro. As a result, the buying position in this forward contract will then have a market value of 50 euro. Okay, this is just one example of a large spectrum of possibilities to get an overview about the determination of the price of a position in a forward contract. It's therefore useful to transfer these considerations on a diagram. It is simple to express the relationship between the value of a forward contract and the market value of the underlying asset at the maturity date with the help of a diagram where we measure the forward contract, the value of the forward contract on the y-axis can be positive and it can be negative as we've seen, and the value of the underlying asset on the x-axis here. If you use such a diagram, then the relationship between the forward contract and the market price of the underlying asset is expressed by such a simple straight line, which cuts the x-axis at the delivery price of 100 euro. To see why this line describes this relationship, let's transfer the numerical example we have just discussed to this diagram. If the market price of the underlying asset equals 150 euro, then the market price of the underlying asset is equal to 50. 50 is equal to the market price of the underlying asset minus the delivery price of the forward contract. Because the buyer can buy the underlying asset with the help of the forward contract at the delivery price of 100 euro, but can sell it at the stock market at a price of 150 euro, this means that he is able to make a profit of 50 euro if he owns the forward contract. So the market value of the forward contract is equal to this profit, 50 euro. Now, if, for example, the underlying asset equals 80 euro, the market price of the underlying asset equals 80 euro, then the market price of the forward contract equals minus 20 euro, because the market price of the forward contract is equal to the market price of the underlying asset minus the delivery price of the forward contract. because the buyer must buy the underlying asset with the forward contract at a delivery price of 100, but can sell it at a market price of only 80 euro. The difference, 20 euro, is the loss this buyer makes if he holds the buying position in such a forward contract. You can try all other points on this green line and you will find that the same works. So the formula for the market price of a buying position in a forward contract at the date of delivery, at the maturity date of the forward contract, is the price of the underlying asset, the market price of the underlying asset, minus the delivery price. This is the equation that describes this straight line in this diagram. For the selling position in a forward contract, the relationship is of course inverse. So the line has this negative slope and cuts the x-axis again at the delivery price. Now let's transfer our numerical example now to the market value of the selling position in a forward contract. If the market price of the underlying asset equals 150 euro, the market price of the selling position in the forward contract equals minus 50 euro. The delivery price of the forward contract minus the market value of the underlying asset. Because the seller must sell the underlying asset at the delivery price of 100, but can buy it only at a market price of 150, so he makes a loss equal to 50 euro. The opposite happens if the market price of the underlying asset is lower than the delivery price, then the selling position in the forward contract has a positive market value of 20. 20 equals the delivery price of 100 minus the market price of 80. Because the seller must sell the underlying asset at the delivery price of 100 and can buy it at a market price of only 80. So he makes a profit in this case equal to 20 euro. We can describe this relationship also with an equation which looks just the opposite as the equation for the buying position. So the market value of the forward contract in the selling position equals the delivery price minus the price of the market value of the underlying asset. Now, what can be done with such a forward contract? I would like to give two examples. Let's first consider an example where the forward contract is used as a perfect hedge. A portfolio of the underlying stock plus the forward contract would be such a perfect hedge. Now, of course, you can ask, why would such a portfolio make sense? Well, for example, if one is only interested in the dividend payment of a stock, for example, if one expects a higher dividend payment than the market, if one has some superior information compared to the market average, one can hedge the price risk of the stock completely away with the help of such a construction. Let's see how it works. What will be the value of a stock plus the corresponding forward contract with a delivery price of 100 euro for the selling party 6 months when the market price of the stock is equal to 100 euro and 6 months date the market price will be 80 euro. Well, for the selling party, this means that it can sell the stock at the market price of 80 euro, and it means that the market price of the selling position in the forward contract is the delivery price minus the market price. So in this case, 100 euro minus 80 euro, which equals 20 euro. So the value of this portfolio for the selling party in the forward contract is 100 euro. Now, if the opposite happens, if the market price of the underlying stock grows to a value of 150 euro, then the selling party can sell the stock at this market price, 150 euro, but the forward contract will now have a negative market price of 50 euro, since the formula tells us the market price of the selling position in the forward contract is the delivery price minus the market value of the underlying asset, so 100 euro minus 150 euro. So the selling position in the forward contract will have a market price of minus 50 euro. If you add this again up, then the value of the portfolio in this situation is also 100 euro. So this means, held together with the underlying asset, the forward contract completely eliminates the risk for the selling party. This is an example how such a forward contract can be used to eliminate completely the risk of holding a portfolio. However, a forward contract can also be used to leverage an investment. Let's use the buying position in a forward contract to demonstrate the opportunities and risk of such an investment. Let's assume that the market price of the underlying asset is 110, such that the forward contract can be bought at a market price of 10 euro. Now, if the market price of the underlying asset grows from 110 to 130, for example, this implies that the market price of the forward contract grows to 30 euro. This implies an investment return of 200% for the forward contract, which we have bought at a market price of 10 euro only. If you would instead have bought the underlying stock of this forward contract, then the investment return would be much lower, namely only 18%. The difference between the market price of the underlying stock minus the investment we had to make to buy this stock. So here the return is much lower if the market price of the stock goes up. But if the market price of the underlying asset, the stock, falls, let's say to 90 euro, then the market price of the forward contract falls to minus 10 euro, as the formula we have just discussed tells us. So this implies now an investment return of minus 200. The money we have used to buy the forward contract minus the value of the forward contract after the price of the underlying asset had fallen to 90 euro. If instead we would have bought the underlying asset at a market price of 110, the value of the return of this investment would be only minus 80 euro. the value of the underlying asset after the price had fallen minus the money we have invested in the underlying asset. So the leverage effect works symmetrically in both directions. It can boost the profit, as in this situation where the market price of the underlying asset grows, but it can also boost the profit, as in this situation where the market price of the underlying asset has fallen. Nevertheless, such an investment can make sense if the investor believes that he has information that the price of the underlying asset will grow, so that we are in this world, which the market does not have. Then it might be even rational to buy the buying position in such a forward contract. Well, now you know how to do such a thing with the help of a forward contract. As shown by the above diagrams, the value of a forward contract to the buyer at maturity date is equal to the difference between the delivery price and the market price of the underlying asset at maturity date. So it is given by this formula. Market value of the forward contract at maturity date, T plus X, is equal to the market price of the underlying asset minus the delivery price. What we have not discussed so far is the price of the forward contract before the maturity date. Well, let's start with the formula and then let's see how we can prove this formula. Formula is quite simple. It looks a lot like this formula, only that we have to divide the delivery price by this interest factor to the power of the remaining time. Where the interest rate is equal to the interest rate of a risk-free security, and x minus n is the time left between the point where we can buy the forward contract and the maturity of the forward contract. So this is the formula that can be used to determine the buying position in the forward contract before maturity date. This formula works empirically quite good. In fact, it was known to market participants even before it had been proven by financial mathematicians. To prove this formula for the buying position in a forward contract, we can use the fact that on an arbitrage-free market, the costs of the various ways of making sure at point in time t plus n that a specific asset is possessed at point in time t plus x must be always the same. If the costs were not the same, then the cheapest possibility would be used until the costs would have equalized. Hence, on arbitrage-free markets, the following equality must hold. You can buy the underlying asset at point in time t plus n and simply keep it until the point in time t plus x. This way of making sure that you own the underlying asset at point in time t plus x must cause the same costs as an alternative possibility. For example, you can buy at point in time t plus n the forward contract, the buying position in a forward contract with a maturity t plus x, and use then this forward contract at point in time t plus x to buy the underlying asset at the delivery price. So both transactions make sure that you own the underlying asset at point in time t plus x. On arbitrage-free markets, both possibilities must cause the same costs. If not, everybody would use the cheaper possibility until the cost difference has disappeared. Now, what are the costs of these two possibilities? The cost of the first possibilities are the interest costs of buying the underlying asset at point in time t plus n. So this is expressed by the price which we have to invest to buy the underlying asset times the interest factor to the power of the remaining time. These costs must be equal to the cost of the second possibility. These costs must be equal to the costs of buying the underlying asset with the help of a forward contract. So these costs are equal to the price of the forward contract in t plus n times the interest costs plus the delivery price of the underlying asset at the maturity of the forward contract at t plus x. So both formulas must yield the same value in an arbitrage-free market. And now it's quite simple algebra. We can solve this equation for the variable which we want to determine, namely the market value of the forward contract at point in time t plus n. So we can subtract the delivery price from both equations, then it appears here on the left side only, and then we divide by the interest factor, and then the interest factor disappears here and reappears as the denominator of this fraction here. And now we have isolated the market value of the forward contract, the buying position in the forward contract at point in time t plus n. And that's now the formula which we wanted to prove when we started. Okay, so much for this lecture. In the next lecture we will talk about options.